Hi, this is Maggie. In this video I'm going to talk about information hiding and visibility in an object-oriented design. To understand information hiding in an object-oriented design, it's helpful to forget about implementation or programming for a moment and think on a more abstract level. We'll use an example of a card game because cards should be familiar to us all, and we'll use the example of one of the games in which cards are compared based on rank and suit is ignored, such as Go Fish or War. So imagine that we decide to break the responsibilities of this system up into two kinds of objects. Game, which is responsible for the rules of whatever game is being played, and deck, which is one standard deck of 52 playing cards. We want to be able to reuse deck, the deck of cards, with different game objects, just as in real life we can use the same deck of cards to play Go Fish, War, one of the many varieties of poker, bridge, etc. When we design the objects, and we use Go Fish and War as examples, we might write a set of responsibilities for the deck class that includes represent a standard deck of 52 playing cards, shuffle, make hand, make discard, show hand, show top card, etc. This example is about information hiding. To keep it simple, we will address only the responsibilities represent standard deck, shuffle, make hand, and show top card. Given those responsibilities, we'll need to decide on a public interface, which is the part of the deck object available for other objects in the system to use to access and manipulate the deck's internal state. We are imagining here that a deck consists of the 52 cards, but those cards might be organized into different piles. Here we're only implementing the ability to deal hands, so the internal state of the deck object is the cards and the organization of the cards into hands and stock. So we can create a public interface, one that might look like an init method, taking no parameters and returning nothing, a shuffle method, taking no parameters and returning nothing, but of course the understanding is that the cards will be in a random order following that operation, a make hand method, taking the number of cards as a parameter and returning some sort of key that will be used to interact with that hand. Let's make that an integer, and finally show top card, which should take the key for the hand whose card we want to look at and will return a string representation of the card. If no key is passed, it will show the top card of the stock. Those responsibilities will become the public interface for any part of the program using the deck, such as the game. If we start to write a game class, let's write one for War, then we will want to have fields which are a deck of cards and two hands. The two hands will be the integer keys, and the deck of cards will be an object of class deck. And in the init method, we'll create a deck, shuffle it, and make two hands. Let's also have a play method. And we'll just ask the deck to show us the top card of each of the hands. Okay, so let's look at an implementation of deck. I'm going to write something and come back because the focus of this video is on information hiding, visibility, and not on implementing a class. Okay, before we talk about the implementation of deck, bear in mind that I wrote the war game, such as it is, without seeing the implementation of deck. I saw the public interface, which are these public methods init, shuffle, make hand, and show top card. We have absolutely no idea how deck is implemented. In fact, before we look at it, let's make a war game and send it the play message, and I'll just have it print the top cards from play just so we have some output we can look at. Okay, and you can see it tells me the top cards in the two hands, which is obviously not a thorough test suite, but it's doing something with the deck, and we have not seen deck yet. That is because the implementation of deck is hidden from us, but the public interface is public, so we know exactly what we need to know to use a deck object. And if the implementation should change, it wouldn't alter the war class at all, as long as the public interface remained the same. So here's the implementation. And here I chose to implement the cards in the deck as a list of integers. I chose to implement hands as a list of lists with the key that's returned the index into the list. And I have a private method that converts the integer version of a card into a string version. Now, ideally you design a class for the system that it's going to be used in, or systems, in the case of this deck, which might be used in different programs. So ideally you don't have to change the implementation, but there are a number of reasons we might change it. For example, something about Python might change that makes a different implementation a better choice. Or we might need to add some functionality to the deck, and that functionality might be easier to implement with a different choice of data structure that has no negative impact on this implementation. To change something relatively small and simple, simply to illustrate that we can change the implementation and it has no effect on parts of the system that use only the public interface, I'll change the hands to use a dictionary rather than a list. I'll pause the video and do that. Okay, so that wasn't much of a difference in the code. I think a more likely change would be to design a card class, but there's no need to do that, simply to illustrate that I can change the implementation of a class, and so long as it maintains its public interface, there are no negative effects on the system or systems that use the class. So I run my program, and the output is the same. There are no effects on the war class because it restricted its use of the deck class to the public interface. Now, in Python, you can access any part of an object, even the parts that are designated private by the underscore. This relates to the design philosophy behind Python, which is that you know what you're doing. Languages that allow you to enforce visibility, like Java, will not allow any methods outside of the object's own methods to access fields or methods designated private. Now here's why you don't access object attributes named with the underscore or designated as private, because there is no guarantee they won't change. If I wrote the war class to directly access the hands field of the deck class, for example, it would break if I changed the hands field to be a dictionary rather than a list, and it would be the fault of the programmer who accessed a private attribute. It's use at your own risk, and if it were translated into a language that enforces visibility, you'd have to rewrite your code because the language would prevent that sort of access. So, do not access attributes with private visibility, even though technically in Python you can, because you are basically creating a ticking time bomb, code that might break in the future and will be very difficult to maintain. To practice with this, you might take some old programs that you've written, make implementation changes to one or more classes that don't affect the public interface, and confirm that your systems still work. If they don't, find where you used the private attributes and either redesign your classes if you needed access you didn't have, or rewrite your program so it no longer violates the visibility indicators. You could also enhance this implementation, think through the deck class and add some more methods, and add some more to the wargame class. For example, you will need to be able to compare cards according to rank. You might write a compare cards method, or maybe compare by rank, with a future enhancement being able to order the suits and compare by rank and suit. Try to make the design general enough that you could write a new game without changing the public interface of the deck class that is used by the wargame. When you can consistently write systems that interact through the public interfaces of objects only, you're ready to move on.